Humans, today's video is discussing parallelograms and trapezoids and the area, or the amount of squared units each shape occupies. Okay, let's get started. Okay, let's take a look at a parallelogram to start. Now, from our experiences, we've known that a parallelogram is something that has two parallel sides, as indicated by my markings on this first figure. What you can do with a parallelogram, pretty crazy, if you cut off what would be a triangle on this left side, as indicated here, you can fit that by bringing it over on this side and make a perfect rectangle. And we all know the area of a rectangle is base times height. So it appears as though every parallelogram takes on those same properties when discussing area. And that's why we can say this fancy thing in a tan box. The area of a parallelogram is the product of the base times the height. So for example, you have a base of 8 meters in a height. Remember, it's dropping a perpendicular from one vertex down to the base at a 90-degree angle. That height is defined as 6, so 8 times 6 is simply 48, and the units meters is squared, because you're talking about the number of squared units inside of the shape. Hooray! This isn't the best drawing, but let's assume that this shape is a parallelogram, opposite sides parallel. And let's see, we've got a height, it appears to be 8 inches, and we have a length, or a base down here, that appears to be 12 inches. Can you find the area of this here parallelogram? Do it. Show me tomorrow. This next shape, trapezoid, is a little more difficult to see the connection, but I think we can. Let's look. You start with the shape trapezoid, where it has two parallel bases. These are parallel. And the height, again, is defined by the perpendicular dropped from one base to the other. If you take a trapezoid and you turn it over on its side and you line it up next to the same duplicate trapezoid, you can see that what you've done in effect is take a look at base 2 and add base 1, and you still have the height. And this is a parallelogram with base 1 and base 2. If you take those bases combined and multiply the height, that should be the area. But that's the area of 2 of these trapezoids. We're looking for half of that area, and that's what's shown down here. Take a trapezoid, flip it over, lay it right next to its original, lay the copy right next to its original, and you can see that the area is nothing more than the first base plus the second base. If you multiply that idea together by the height, that's the area of the parallelogram that's formed. But really, you're only looking for half of that, which is the trapezoid. So that's why we can define the area of any trapezoid like this, right here. See if that makes sense to you, and see if you can see how they've gotten this example. Here's the math for it. It's the sum of the bases, 5 and 7, right here. Multiplying the height, right here. And you're taking half of whatever that result is. 5 plus 7 is 12 times 4, and you're taking half. Well, 12 times 4 is 48, but you want half, which is 24. And we're looking at the units squared because we're talking about area. Pretty cool. Let's do one. Now, these are the easy problems, and tomorrow in class we're going to step up our game a little bit. But these are pretty straightforward. This is a trapezoid because you can see that opposite that has a pair of parallel sides, four-sided figure, trapezoid. Let's go ahead and find its area. Use the formula from the previous page. Find the area in inches squared or squared inches. Show me tomorrow. Bye.